Again, welcome to PH 660 class. This is Biostatistics 1. In these lectures, we're going to discuss about binomial probability distributions, which cover chapter 6 of our course textbook. So our main objective is to go through what is a binomial random variable, also how to calculate binomial probabilities and cumulative probabilities, also expected values, variance of a binomial random variables. Also, how to use the binomial distribution to help make judgments. So first, we go through what is a binomial random variable. So a binomial is a family of discrete random variables. As we said in our previous lectures, a discrete random variables is based on, again, counting. Our data will be based on counting. So for example, how many patients the doctor saw yesterday is how many, so it's counting. Now, what is the average weight of the patients that the doctor saw yesterday? Or what is their average blood pressure? And this is measurement. Pressure is measurement. Weight is measurement. So that's a continuous random variable. Discrete is counting. Continuous is, again, measurement. And the concept of a binomial is that our output will be by 2. By means 2. So most of all the trials that we will research works on binomial probability distribution, the outcome have to be 2, and also the random variable have to be discrete. The data have to be based on counting. So example here, we say binomial random variable is the random number of success in n independent Bernoulli trials. Bernoulli trials have only 2 outcomes. Here we say it has 2 possible outcomes, either true or false, success or failure, positive or negative. So a binomial probability distribution conditions, at least the 2 major condition is the outcome of the research studies is only 2, yes or no, success or failure, positive or negative. And also the random variable data must be based on counting. So a very simple example is, let's say we have 20 flights every day from JFK to London. Out of these 20 flights every day, based on the previous years or months of flights daily, we found out that 75% of the flights make it in time. So that means we have only 25% failure. Now, if a question is given, what is the probability that 3 of the flights will make it in time? Now, this is a binomial probability distribution question. Why? Because here the outcome is only 2. Either the flight will be late or it will reach in time. And that's what we are testing, late or not late. And secondly, the random variable is based on counting, because here we are talking about the number of flights. Our n value will be the total flight, which is 20 flights a day. What we are testing is the random variable. We say, what is the probability that the 3 flights will reach in time? So which means our random variable will be 3. Now you can see that this random variable is discrete random variable, because the outcome of the variable is either the flight is late or it's in time. And secondly, we count it 3 flights. So this will be, again, an example of a binomial probability distribution question. So here we are going to use some notation. First, we know the lowercase n is the number of tries. And this time the P here means probability of success of each try. So a binomial random variables have 2 parameters, the number of tries, then the probability of success of each try. In our example, which I mentioned, the number of tries is the 20 flights per day, the total flights per day from JFK to London. Then the P, the probability of success of each try, is 75% based on the previous flights. 75% chance that, or 0.75 that chance that again the flight will make in time. So there's an example here. Now let's go through this example. Here the example said we should consider the random number of successful treatment when treating 4 patients. So our question here is that we have 4 patients that a doctor is going to treat. The probability of success of these 4 patients in the previous events or previous result, there's a 75% chance that all the 4 patients will be treated successfully. So that's 0.75. Now we have a random number of success can vary from what? 0 to 4, because the total patients is 4. In our flight example, we have 20 flights a day, and I was looking for the probability that the 3 of them will be in time. Now my random possible variables will be from what? 0 to 20, because we can have up to 20 flights. Now I cannot say that I have a total 4 patients. I cannot have a question that what is the probability that 5 patients will be treated successfully? The highest is 4. We don't have 5. So that's why here we are saying the random number of success can vary from 0 to 4. Now the random number of success is a binomial with parameters n equal to 4. 4 is our total patients we have. Then P, which is the probability of success, 0.75. It's binomial. Why? Because the outcome of the patient will be either treated or not treated, and also based on counting. So the notation here will say B for binomial, we have 2 parameters, the number of tries, which is n, and P again is the probability of success. So in this our example, n is 4, P is 0.75. So now we go to how to calculate the binomial probabilities. This is the formula we use. So to find the probability, again, this condition is only for binomial. So when we start with a normal distribution or hypergeometry or uniform, they all have different formulas of finding the probability. So this is again probability of binomial condition. The formula is C, which sometimes we use the term combination, or in this textbook, they use the term binomial coefficient. So binomial coefficient C with n and x, p to the power s, q to the power n minus x. So q is the probability of failure. So that means if we know the p, q will be 1 minus p, complement rule. So since P is probability of success, then probability of failure should be 1 minus P. N, as we said earlier, is our number of tries. Then X is our discrete random variable, what we are looking for. So let's start with the example. As we can see the formula here, the binomial coefficient, there's a formula that we have to use to find it, which will be the n factorial divided by x factorial n minus x factorial. A factorial of a number means you multiply the number by decreasing it until you reach 1. So for example, a factorial of 2 will be 2 times 1. A factorial of 3 will be 3 times 2 times 1. A factorial of 5 or 6 will be 6 times 5 times 4 times 3 times 2 times 1. So this is the formula again. The binomial coefficient nx is n factorial divided by x factorial n minus x factorial. As we said earlier, the exclamation represents factorial function. So x factorial will be s times s minus 1 times s minus 2 all the way to 1. So example given here, to find a 4 factorial, it will be 4 times 3 times 2 times 1, which will give me 24. By definition, the factorial of 1 is 1, and also the factorial of 0 also is 1. So to find this, let's say we have a total trial of 4. The N is 4. What is the probability that 2 of the patients will be successful? So first, we have to find the binomial coefficient, which is 4 and 2. So it will be 4 factorial divided by 2 factorial, then 4 minus 2 factorial. So we get 4 factorial, 2 factorial multiplied by 2 factorial. Why? Because 4 minus 2 is 2. Then we said the 4 factorial will be what? 4 times 3 times 2 times 1. Then 2 factorial will be 2 times 1. Another 2 factorial, 2 times 1. Again, we can write it in increasing order. So 4 factorial can be 1 times 2 times 3 times 4 also. So here we can say 2 times 2 is 4 here. So the down here we have 4. So that can cancel the 4 at the top. Then we are left with 3 times 2 times 1, which will give us 6. So this is the formula again. Binomial coefficient of n and x is n factorial divided by x factorial n minus x factorial. So we say the binomial coefficient is called the choose function because it tells you the number of ways you could choose s items out of n. And again, some textbook will use the term combination. It's called a combination function because it tells us the possible number of times we can combine x inside n. So combination choose is the same, the number of ways to choose s items out of n, or the number of ways to combine x items out of n. So for example, if I have C for 2, it means we can do 6 different combinations or 6 ways to choose 2 items out of 4. So they say we should recall the previous example again. We have 4 patients, if you quite remember, and also the probability of treating them successful was given to be 75%, which is again 0.75. So if I'm going to find the probability that there will be a failure, which means we cannot successfully treat all the 4 patients, is Q equal to 1 minus 0.75, which will give me 0.25. So now if I know the N, and I know the X, and I know the P, and I know the Q, I can find any probability of any random variable. But here we have 4 patients, so you have to be between 0 to 4. So the first example is here given. What is the probability of observing 0 success under this condition? So we go with the formula again, and we have binomial coefficient n and x, probability of success p to the power x, probability of failure q to the power n minus x. N is total trial, x is what we are looking for. Our x here is 0. What is the probability that nobody will be treated or 0 patients will be treated? So we plug in the value. How many patients we have? 4. And x is 0. That's our condition. No patient will be treated. Then probability of success was 0.75 raised to the power 0 times 0.25 because 1 minus 0.75 will give me 0.25, which is the probability of failure. And again, n is 4 minus 0. So we get 4 factorial, 0 factorial times 4 factorial. Remember, 0 factorial is 1. So here we get 4 factorial divided by 4 factorial, which will give us 1. Now, any value raised to the power 0, it doesn't matter what value. The answer is always 1 also. Then we can use our calculator to find 0.25 to the power 4, which is 0.0039. So our answer will be 0.0039. So the probability of not treating any patient or treating 0 patient is 0.0039 or 0.39%. So we have example also for 1. What is the probability that only 1 patient will be treated successfully? So we can say our binomial coefficient is 4 to 1. So success raised to the power x is 1. the probability of failure raised to the power n minus x, so 4 minus 1. And then when we solve this problem, 4 factorial divided by 1 factorial and 4 minus 3 factorial, that will give me 4 factorial over 3 factorial. So when I open 3 factorial, I'll get 3 times 2 times 1. When I open 4 factorial, I'll get 4 times 3 times 2 times 1. So we can see that 3, 2, 1 will cancel the up and down. So it will lead to 4, so our 4. Then here it's raised to the power 1, so that will give us 0.75. Now we can use our calculator to find 0.25 raised to the power 3, which will give us 0.0156. Multiply the 3 values here, 4 times 0.75 times 0.0156, and that will give me 0.0469. The next question is, what is the probability that 2 patients will be treated successfully? So our choose function, or the combination, is 4 and 2. P will raise to the power 2 because this time our random variable is 2. Then 0.25 will raise to the power 4 minus 2. So when we do our formula, which we get 4 factorial divided by 2 factorial times 4 minus 2 factorial, our answer we get is 6. When we square 0.75, we get 0.5625. Then square 0.25, you get 0.0625. So when we multiply the 3 values here, 6 times 0.5625 times 0.0625, that will give us 0.2106. So that will be our probability of having 2 patients treated successfully. Or we can also say it's 21%. Okay, so we do the 3 and 4 also. So what is the probability that 3 patients will be treated successfully? So we have 4 and 3, 0.75 to the power 3, 0.25 to the power n minus x, so 4 minus 3. So 4 and 3 will give us 4. If we use the formula again, 4 factorial divided by 3 factorial times 4 minus 3 factorial. We can see that 1 factorial will be left, 4 minus 3. The other is again 3 factorial. The top we have 4 factorial, so 4 times 3 times 2 times 1, and the down will be 3 times 2 times 1. So we cancel everything and it will let it only 4 at the top. Then find the cube of 0.75, that will give us 0.4219. Then here we have 0.25 to the power 1, so that will give us 0.25. Multiply the 3 values here, our solution will be 0.4219. And the last possible option now, what is the probability that all the 4 patients will be treated successfully now? So it will be 4 to 4. When the possible combination is the same, 4 to 4 here, n and x, we always get 1. We get 1. So here we get 0.75 to the power 4. But here also we get 0.25, 4 minus 4, which is 0. Any value raised to the power 0 also is 1. So our solution here will give us 0.3164. So this is quite example, 4 examples, how to find the probabilities of success based on the random variable. Again, this is discrete, so you can see that the example here we are talking about how many patients are going to be treated successfully. So it's discrete. Treatment, only 2 outcomes, either successful or failure. So that's why it's a binomial. Now, cumulative probability, what cumulative means is that we're always going to add the previous answers to it. It's the same thing we did in the frequency tables or frequency distribution. We can find the cumulative relative frequency. Cumulative relative frequency means you add the previous relative frequency value to the present one. So the same thing applies here. For example, this is what we just find, 0 to 4. These are all the probability values we just did right now. Now, if they say, what is the probability that the patients when that will be treated successful will be less than or equal to 2. Less than or equal to 2 means from 0 to 2. So I'm going to add all these 3. Or greater than, let's say greater than 3. If it's greater than 3, 3 is 4210. Only one value is greater than 3, so my answer will be only 1, 0.3164. Now, if they said it's greater than or equal to 3, then I'm going to increase. So we get a cumulative of 0.4210 plus 0.3164. That is greater than or equal to 3. So we also have something we call the area under the curve. If we can recall the area under the curve concept in the previous lectures, this is example. So area under the curve here, for example, we have an histogram. We want to find the probability of 2. So we find the area of the box or the rectangle, which will be the length times the width. So we get 0.2109 times 1. And our answer will be the same 0.2109. So area under the curve give you the value of the probability. So now we have example here. What's the probability that the x will be less than or equal to 2? Which means I'm going to add the probability of 0 plus 1 plus 2. So that's what we did here. You can see our marker. We can see our mark area. This is 2, 1, and 0. So we have to add all this. Now let's go back again. What's the probability that s is greater than 4? It's 0. There's nothing here. Because if we go up to 4, we don't have greater than 4. So cumulative probability function normally will list all the cumulative probability for all possible outcomes based on your condition too. My condition here is, for example, what is the probability that s is less than or equal to 0? So that is the condition, less than or equal to 0. We start from 0, so we get only 0.003 now. What is x less than or equal to 1? So we get 0 and 1. So whatever value we have in 0 plus the 1, and it will give us 0.0509. Less than or equal to 2 means you had 0 and 1 and 2 together. Then less than or equal to 4 means 0 plus 1 plus 2 plus 3. Then less than or equal to 4, that is the last value, so you always get 1. If you remember the frequency distribution, cumulative relative frequency, the last value always is again 1. So these are the calculations. And for 4 is 1 because we had all the values. So next we move to the expected value and variance for binomials. Expected value is the same as the mean. So we may have a question, what is the mean of the binomial probability distribution or binomial mass function? Here we use the formula n times p, that's it. So we have the formula here. The mean of, again, binomial probability distribution is the number of tries times the probability of success. So mu is NP. And then the variance will be NPQ. So which means the standard deviation will be the square root of N times P times Q. Again, N is the total tries, P is the probability of success, Q is the probability of failure. Anytime we know the P, we cease it to know the Q because 1 minus P gives us Q. If you know the Q and you don't know the P, it's easy also, which means if I know the Q, it will be 1 minus Q will give me P. So this is example, the same question again for patients. Now we already know that the total try is 4 patients, so N is 4. And the probability of success was 0.75. So if the question said we should find the expected value, then it will be N times P. N is 4, P is 0.75, which gives us 3. Now, if they say we should find the standard deviation, then it will be NPQ. Since I know the N to be 4, P is 0.75, then Q will be 1 minus 0.75, which is 0.25. So our final answer will be 4 times 0.75 times 0.25, and that gives us 0.75. Now, if I want to find the standard deviation, then it will be square root of 0.75. And the purpose of you finding the mean and the variance or standard deviation in binomial distribution is the same as descriptive statistics. We want to find the center of the distribution. And also we want to find how the data is, the variation of the data, how far they vary. So when the variation is very high, you see that the graph will be wide. If the variation is very small, then the graph will shrink in. So the mean and standard deviation give us the center tendency of the data and also the dispersion or variation of the data. So we can see our center mu is 3. Here now we say using the binomial. So suppose we observe 2 success in the 4 patients. So we have 2 success in the 4 patients. And we know the example mu is 3, suggesting that we should see 3 success on average. Now the question is, does the observation of 2 success cast doubt on P equal to 0.75? We say no. Why no? Because the probability of S is less than or equal to 2 is 0.2617. It's not too unusual. So again, as we said, the mean and the variance tells us how the data varies, which is for the variance or standard deviation, and also the center of the value, which is for the mean. Next, also, we can use the stat table probability calculators, especially when we go online. There are so many software online that we can use to calculate our probability, binomial probability distribution. So this is an example here. We enter our N, we enter our P, and it will give us the answer. So N is 4. What is the probability that 2 will be successful? The P is 0.75. And when you click it, it gives us the same answer. So this will be the conclusion of a binomial probability distribution. Actually, before we go, let me see if I can get into the internet and show. So for example, the last example I was talking about the calculator. If you Google, I'm going to Google binomial probability calculator right here. And again, I'll go to the first option. And we should see, so this is an application. So probability of success on a single try, we can write that, the number of tries, then the number of success, and it should give us the, we also have the cumulative probability. Now it depends if you enter a condition answer. So for example, the number of probability of success, let's say is 0.75, and the number of tries is 4 patients, and I'm looking for a probability of 0. And when I click on calculate, I can see the button here. We have an advertisement here. Okay, so I click on the calculate. You can see that we have the answer to be 0.0039. If you remember, our calculation was 0.0039, but this calculator gives us 6 decimal places, more than even 6, around 8 decimal places. Our answer was 4 decimal places. This is 8. But the same answer, 0.00390625. And want us to go back to the answer again. So we can see here we have 0.0039 when it's 0, S is 0. And the calculator, we have 0.00390625. So again, they are all the same. So I'm going to end the lectures here. Again, these lectures, we cover the binomial probability distribution. We said the binomial probability distribution is based on discrete random variable, which means it's based on counting. Bi means 2, so the outcome always have to be only 2. True or false, positive or negative, success or failure. And also when we are looking for the binomial distribution probability, we need to know the n, which is the number of try. X is our random variable value. Then we need to know the p, probability of success. Now, if we know the p, then we know the q, because q will be 1 minus p. And those are the values we need to find the probability of a binomial probability distribution. We also talk about the expected value, which is the same as the mean. In binomial probability distribution, the expected value is n times p. That's the number of try times the probability of success. The variance will be n times p times q. And the standard deviation will be square root of the variance. And also, the reason why we find the mean, which is the expected value, and also the variance or standard deviation, is to know the center of the distribution. That is the central tendency. And also to know how the values are varies, dispersion of the values in the data set. So I'm going to end here, and I wish everybody the best, and see you in chapter 7. We're going to discuss about normal probability distribution. Again, normal probability distribution is continuous random variable. So it will be based on measurement. Again, thank you. Bye.